privilege to be a sponsor at this conference for so many years, and exciting to see all the recent developments. From our perspective, I think one of the things we really see revolutionizing the industry is artificial intelligence. And there's certainly been a plethora of panels and papers and comments specifically about artificial intelligence. I'm just interested in the audience's background here. How many people really came to the conference knowing almost nothing about artificial intelligence and surprised to see it to be so active? Is anybody willing to admit? Okay, good. It's great. That's what this conference is all about. How many people have had some exposure to artificial intelligence? Maybe you're using ChatGPT a little bit, and think you probably need to know more to kind of keep current. So how many people in that category? How many people are using artificial intelligence as part of your flight software engineering responsibilities, your supporting tasks? You're using more advanced tools to do specific things. Good. A couple more categories. How many people are implementing artificial intelligence components in the products and services that you're providing? Good. And how many people here consider themselves an expert in artificial intelligence and really just came here to argue with me about my charts? Okay, good. I always good to pick those people out early here. We're going to talk a little bit about artificial intelligence, and I did just a survey kind of to look at where some of the areas are that are in flight software that we're using artificial intelligence. And I'll talk a little bit technically about some of the challenges I see a little later in the presentation, but I was really sort of surprised. I think before I started this research, I knew about a couple of these areas, and I was kind of familiar with a few things, but I'm really surprised at the duration of it. And I think part of that is because the companies that are using artificial intelligence now see such tremendous leverage in it that they're basically keeping quiet. They may be telling their customers or your customers, right? But they're generally not sharing much at a conference like this, except to just kind of make basic awareness. So anyway, safety, I think it's a very obvious area where artificial intelligence helps. To me, artificial intelligence shines where you have a complex situation. You need kind of immediate response to maybe some unknown conditions. Probably if you had some combination of a savant and a video jockey at the ready, maybe you could do that. But often the sort of detections we get, I think certainly aviation safety areas like autonomy detection and decision making, et cetera, it's probably been one of the more common, one of the more recent uses. Do we have anybody here who's currently using it in a safety capacity? Okay, I think it's a great opportunity to look for that, look for components here. Maintenance. We're starting to really recognize, I think maybe some of us have recognized for many years, how critical maintenance is and how much a driver and cost that is. So for example, one of our instructors works at Boeing, and Boeing is very extensively using artificial intelligence in some of their preventative maintenance activities. They're even using for optimizing maintenance schedules. I've worked with one of our major clients is Northrop Grumman. They're using that and have been using that on programs like Minuteman to do replacement prediction and that sort of thing. Especially given some of the tangential challenges like supply chain challenges that have emerged over the last decade or so. It's really important to be able to anticipate things. I can't just run off and get some of the components that I need off the shelf. So doing that, I think there's some huge cost savings, time savings, resource savings associated with the maintenance area. Anybody here using AI in aviation maintenance? Okay, lots of opportunities here. Flight planning and optimization, probably an early area where we identified kind of advanced algorithms, et cetera, being useful for. I was surprised to see the extent of the different references out there in literature for flight planning and optimization. What I didn't see a lot in the open literature was how much time this is saving and how much better some of this is happening. I think sometimes when I'm taking flights, I try to, I'm not sure there's any optimization of my flight going on at all. We sat on the runway the other day for 45 minutes for, I don't know, maybe a bird walked across the runway. I'm not exactly sure, but certainly I appreciate the way that we can route around weather and other sorts of things. And again, I think flight planning and optimization, we also have to kind of think more broadly beyond the aviation industry and think about spacecraft and flight planning. I think we've got a number of different things. We work a lot with JPL, and we've had a couple of JPL speakers here at the conference and some very amazing things on like path planning for the rover and stuff automated there, which can be a very onerous problem. And they also have the delay in terms of the time delay in terms of signals. And the standard way to drive a rover is you look at where you want to go, you argue about where you want to go next, you send a command, the rover moves a few inches, that all takes, half an hour, and then you move another couple inches forward. Obviously, some sort of artificial intelligence work can really speed up and optimize that process. And since you're limited by the amount of time that the equipment's going to be able to work for you and the amount of time during the solar day there, very, very impressive. Anybody here using AI in flight planning optimization? Okay, I'm seeing lots of potentials here. Air traffic management, again, kind of related area here, traffic flow, conflict detection. This is something as a passenger I really appreciate. I'd like to kind of keep to my airspace by myself. Anybody using it in air traffic management? Okay. Passenger experience. And again, I think that's one of those generic areas you could think about. How do I use AI in general to make the customer experience better? You're going to see a huge explosion in that over the next 4 or 5 years because commercial companies have recognized that AI can be used to really personalize a customer experience, right? This goes beyond just Amazon saying, gee, if you like this book, you might like this book, or maybe we could book you tickets. But things like natural language processing and other recognition, the way we interface, buy things, our provided services, I think is undergoing a dramatic change. Some of my friends outside the engineering world, they're just starting to see things. They see a Waymo autonomous taxi, or they are surprised that Amazon can anticipate something, or their Siri or their other voice-enabled systems, respond in some sort of amazing way to them. They're just scratching the surface because that's where the big money is. And I think that's something we can think about, how can we assist operators? How can we assist maintenance personnel? How can we assist customers? How can we personalize experiences for them? And I think we have some real tremendous opportunities. Anybody using AI in kind of stakeholder experience, passenger experience, anything like that? Okay. So what does the future hold here? I think, we've certainly been exposed at this conference to lots of good ideas, and we've seen kind of the cutting edge of where we're going. It's very exciting. Great talks in terms of things like autonomy. I think, we've got smart airports, other things there. I think a lot of societal goals are challenging us. Things like supportability, things like dealing with urban sprawl, climate change, all kinds of things are going to drive. I think the exciting thing about being an engineer today is the rest of the world is starting to realize we geeks are running the place and have been running the place, and the solution to society's problems are engineering solutions. So I think the potential for us is incredibly great. Has anybody seen things that were surprised at? Everybody know all this already, but anything surprises in there? I hope it kind of motivated you, and maybe you saw your area and were surprised to find that it is. I would encourage you to really go off and do that. I'm going to use the rest of my time just for some closing remarks, kind of just looking a little bit more depth about flight software engineer. So if you saw a presentation I did yesterday, I sort of led into some of this, and I want to take my time and give a little bit more detail today on this. But I think specifically we ought to think about two different things. How is flight software engineering different with artificial intelligence components? And how would artificial intelligence change the way that flight software engineering is being performed? Okay, can it assist us in our day-to-day tasks that we do, design, development, manufacturing, maintenance, et cetera? So several slides here just kind of talking about it. First of all, let's look at the left side. How is systems engineering different with AI components? Yesterday in my talk, I talked a little bit about kind of the dynamic and adaptive behavior, how that changes the way we even think about our design paradigms and work with systems, right? And the variability that's introduced with AI components in our systems. I think one of the things that you're starting to see more in the news and the general AI literature now is the discussion. We're running out of data, right? The performance of our AI systems is really dependent upon data. And that's a challenge that we have as engineers, is just feeding the beast, getting enough data in. Traditionally, we've had very structured data streams, but we now need data for training, we need data for processing and learning, adaptability, et cetera. And so we need to be thinking about how do we provide good quality, large volume data to systems so that our AI systems can really work at their peak capacity. The whole uncertainty and explainability, and just understanding the answers we get back, that becomes really challenging if you're in a real-time system. So I think we are used to, certainly in my career, I worked with largely deterministic systems. Yeah, there was some statistics going on, but I could largely characterize that. Some of the deep learning models, it's tough to understand or figure out how they got to the answers that they got to. And we'll find that. And I think that's a critical issue to solve, because that's what makes us tend to distrust AI. What if they decided to do this that doesn't make sense to us, but might make perfect sense to the AI engine, right? We as engineers, we're hired to explain things. Why is the system doing that? If you've ever served on an anomaly board, that's the whole name of the game. How did we get here? What happened, and how do we get out of here? How do we prevent getting in here again? All right. Verification, validation, again, critical issues here. Please forgive me if you're working in verification and validation. If I say today it's relatively straightforward, I realize there's challenges in testing our systems, but the challenges go into hyperspace on when you're dealing with AI systems, because they're adapting and they're changing. A system that works correctly today may not work correctly in the future, and very difficult to sometimes predict it, and to decide, well, how much testing is enough. We're working with a lot of companies now that are building AI systems, and that tends to be the big challenge now. They test it for a while, and then at some point they say, gee, I'm not sure whether we should continue testing or we feel comfortable. Performance, scalability, I think also an issue, right? We want to think about what that even means to an AI system. Things like accuracy, precision, all become critical. Security, robustness, a lot of issues we could say there, cybersecurity. That tends to be some of the critical issues for some of the manufacturers. We work with some autonomous car manufacturers. They're worried about two things. Number one, how do we prevent our system from being hacked, right? And number two, how do we convince a passenger that everything inside the autonomous vehicle is working correctly? Most people, anybody take an autonomous taxi before? So they have them in Los Angeles, San Francisco, Phoenix right now. Waymo is the kind of common brand. By the way, you want to take one, cheaper than a regular taxi, but in most urban areas, they don't let them go on the freeway. So plan a little extra time because they'll take all surface streets to get back to the airport. That's an area I think that we really have to sort of explore. All right, let's look at the other side of the equation here. A couple minutes we have left. How does it affect our area? So if you're doing requirements analysis and management, I think there's well-proven methods now. We're seeing tools emerge on the market for helping to manage requirements. We're seeing natural language processing. We have actually worked with some instructors building tools that can do things like query a set of stakeholders and then automatically build the requirement spec from that, or take an existing requirement spec and check that against standards for the quality of that spec, right? Or even evaluate a design against a set of requirements, et cetera. System design optimization, there isn't a lot in the open literature here because I think the people that are figuring this out are really quiet about it. But you can obviously see the value in terms of generative design. I can put all of my company's past designs into an AI system and I can say, keep generating it, okay? Does that mean AI is gonna replace us engineers? I think teams of engineers will be replaced by one smart AI-enabled engineer and an AI engine. So I think that we're gonna find that that's simply the way to do it. Simulation modeling, another area we could talk about it. On one of our classes, we actually have students use a tool and they build a whole model-based systems engineering model from just a couple simple queries at the very beginning. So we're now starting to open up engineering activities to people who are not classically trained engineers in these kind of areas. Predictive maintenance, we talked about a little bit. Reliability area, I think we can do those kind of activities, and we can enable a lot of our engineering analysis with AI systems to help us do things. Think of like an FMEA that would be enabled by all the past failures that have been seen for that type of component. Testing and validation, there's a lot of grunt work associated with testing, test case generation, et cetera. I think AI can be a real time help for us again. And again, I'm not talking about, replacing your team of engineers with a bunch of AI tools. What I'm talking about is putting AI tools in the hands of competent, smart, creative engineers to enhance what they do to make their work more effective. We deal with reams of knowledge, and as systems get more complex, the knowledge needs will be more complex. And so I think there's a lot we can do there with AI and is being done in terms of just managing the data, documentation, providing things. We work with one company and they've automated all their maintenance now. So they have the typical maintenance engineer who goes out to the field and repairs a system, has access to some very sophisticated AI tools to help them with their diagnosis. Cybersecurity and resilience, another area that the literature is pretty quiet about, but I'm aware that several companies are looking into that and have done a lot of things. I just hope that we're continuing to be ahead of all the bad guys in that area. Okay, hopefully I've given you just kind of some thoughts to think about it. If you haven't gotten into AI, I would suggest you get more. If you're into it a little bit, I suggest you maybe want to get more into it. We can help with that. We have a variety of courses, and so over there on the table, I put a flyer. If you're interested in some of our public courses, it'll give you some codes you can read about things. One of the things we're especially excited about is the AI lab for engineering and scientists, some practical tools for how to use AI tools in your engineering activities, how to build and engineer things with AI components in it. That is a tool that we teach to every professor, postgraduate, and staffer at Caltech. Okay, so that's something that they have considered absolutely essential. Other things, we have a really exciting class called AI Tools for Everyone. That's basically 4 2-hour classes, 1 hour each on the top AI tools, top 8 AI tools used in industry today. That's a free course, so you can go online and do that. We've had really good feedback. And if you'd like to get more involved and your executive is the one that's stopping you, might suggest that they get into our AI for Executives class. That is a good way for helping senior leaders understand what to do about AI, how to foster it within their organization. What are the key steps? What trainings are necessary? What tools are out there? What advantages can you give your business? So with that, I think I have maybe a minute or two for a couple questions. This is the problem with being right before lunch.
All right, there is a question online. I'll go. All right, so are there any efforts you are aware of to characterize the trustworthiness of auto-generated documentation, example, AI-generated design requirements and other knowledge extraction?
To characterize the what? I missed one little part.
Characterize the trustworthiness of auto-generated documentation.
Yeah, I think a lot of people worry the trustworthiness issue. I frankly think it's a bigger issue than we think of, right? It's not like we engineers are incapable of making mistakes as well. But there are some areas trying to at least bound that, or at least figure out the right safeguards to put in to maybe limit. I think of them like bumper lanes in bowling. You know, how can you prevent the AI system from doing something which is clearly, obviously disastrous in some way? So yeah, there's actually quite a bit of work going on there.
Okay, thank you. Next.
I started worked for the Hughes Aircraft Artificial Intelligence Lab back in 1981. But that industry kind of died down like towards 91 because of the liability or accountability issue.
Yeah.
So where do we stand now? So like if I write in Waymo, is it a fault of the designer who designed the autonomous system, or is it a company? Is it I mean, where does the accountability, the liability stand?
Yeah, so I think it's not any different than any of the systems we build. You know, if you're in a Waymo vehicle now and it's involved in an accident, you're going to determine, was it the driver's problem, which is still Waymo's problem for submitting that port as a qualified driver? Is it an equipment problem, which is still Waymo's problem for not maintaining that equipment? And, you know, there are laws concerning what's sort of reasonable expectations of a company for providing like a safe driver and a safe vehicle, right? Those are not different with AI, right? So if the AI system goes haywire and crashes you, right, that's the AI system, but it's the company's fault for not thoroughly designing, developing, testing that system. So I don't think it's any fundamental difference. If I think of AI like just another person who stands there, happens to be really smart and has access to a lot of data, that same paradigm is what's being applied today. Will that change? There's some AI ethics work going on. I think that hasn't been an issue that they've addressed it, but I think it doesn't really change the landscape. AI developer who with a company who designed the AI system? Yeah, I mean, if my driver, you know, did something foolish and it was as a result caused the accident, I'd go back. What were our hiring procedures? How well did we, you know, screen the driver? How well did we trust that driver's capability? Did we have metrics on that driver's performance that led us to believe that he or she might be an unsafe driver? Same thing, you're going to go back to the AI design process and say, what did we miss? How did we build in something? What was the issue? And I think the same issues of liability apply.
We can take the next question.
So a lot of what you were talking about for use cases seem like they could also be addressed by better automation rather than AI.
Yeah,
So where AI may be better, you lose the insight. So where do you draw the line between good enough with insight and better without insight?
yeah. I think the difference is, automated systems are going to maybe lack the adaptability. If it gets presented with situations which the designer didn't anticipate. Now, we live in a very uncertain world, right? And we're applying our systems in domains that we didn't really expect to apply them in situations that we didn't really expect to apply. That's where it shines. The explainability problem, I think, is getting addressed very quickly. We think of it as an issue now because we hear about the AI nonsensical answers that people get out of ChatGPT and stuff. I think that's, when that happens in real life and our engineer gives us an unexplainable answer, we typically say, how did you get there? And they can explain that. A lot of work going out right now into explainable AI. That's actually a field. If you Google explainable AI, you can see the kind of current trends there. The big thing is the flight software engineering industry is not driving AI advancement. This huge global wave is driving that. I just got back from 2 conferences in the Middle East, one Dubai, one Riyadh. 2 AI-focused conferences. Each of them had over 210,000 attendees, right? That's what's going to drive our advances. So as flight software engineers, our job is to ride that wave and be thankful. Explainability will, in my opinion, will increase dramatically in the next 2 years.
Very good. Thank you so much, Rick.